Over the last several months, I've been developing an Android application, and I've recorded lessons to show how I've developed the application. Of course, using the Agile framework, there's more that I will continue to do, and I will probably continue to create more videos. But at this point, the application is essentially done. So I get to describe the development process of the application, describe some of the tools that I use to develop the application, and some of the ingredients that I put together to develop the application, like parsing JSON data, Jetpack composed with Android, Room Database, Firebase Authentication, which is cloud-based authentication, Firebase Cloud Storage, and Firebase Cloud Firestore, which again are some cloud-based functions, GPS, Google Maps, and a whole bunch of things. So the neat thing now is I get to show you that finished product and give you an introduction into the videos that are coming, where we build. This application is very timely and leading edge and takes advantage of a lot of new things that we'll see in the later versions of Android, things like Kotlin, Jetpack Compose, and the other things I mentioned, Firebase, so on and so forth. So I'm going to start by talking a little bit about the development process I used to create this application, and more specifically, how you can find source code for a very specific feature in isolation without worrying about subsequent steps that happened after this, because this is a story I'm telling, a story over several chapters, and I want to help you to find the chapter that helps you to accomplish what you want to accomplish. So we'll talk about development processes, talk about some of the features used, and I'll give a little demo, and then we'll talk about future expansion. I really love Android development. I have been teaching it since about the 2010-2011 school year, and I've seen it blossom from what essentially was experimental, and we weren't quite sure if it was just going to be used for games and other fun things, or if it was really going to take off. That was the early days, all the way up to today, where we see that a lot of companies have changed from a web-first concept to a mobile-first concept, because mobile phones are simply convenient. They're always with you. You can use your phone while you're waiting in line, while you're on the bus. Not so easy to use a browser on a traditional laptop or traditional computer then. But then we also have the additional capabilities of the mobile device. And we, as software developers, get to consider how to put these capabilities together to make great things. Things like GPS, camera, contacts list, all kinds of other things like that. Also integrating data by consuming JSON data from a RESTful service and mixing it with some kind of proprietary data that might be user-generated data. So the potential is simply enormous for the kind of app that you can write that can really make a difference, really change the world. And that's what I love about this, because a theme that you'll hear me talk about a lot is that the Bill Nye theory that everybody I meet knows something I don't. Everybody I meet has an idea for an app that I never thought about. And I really hope that you have an idea that you're passionate about and that you can use this playlist or this video series to implement your idea and do something great. It's really neat because the barrier to entry is low, lower than it's ever been before. Write an app, that's something you could do for fun, that's something you could do for a hobby. Integrate with JSON services, RESTful services. There are many sources of data that are available for free, and you can just go find them and integrate them. Then you have the camera, you have the GPS, so on and so forth. These will start giving you ideas, and then you can create an app. To deploy it on the Play Store, you pay a one-time $25 fee, and the Play Store handles distribution of your application. So on the one end, we have all of these ingredients that we can put together to make something truly wonderful. And then after we've made that wonderful thing, we can deploy it, and we don't have to worry about a lot of the things that we would have had to worry about maybe 20, 30 years ago when we would purchase software in a store and it was shrink-wrapped in a box. Think about all that. You'd have to put it on media. You'd have to get the box designed. You have to get it, distributed. You have to convince retailers to carry your software. There's a huge barrier to entry we had back in the 90s. Now that simply doesn't exist. So the only thing standing between you, your fabulous idea, and getting that fabulous idea to market is simply the effort and the knowledge to take all of these ingredients and put them together. And I certainly hope that this playlist gives you that missing piece, because I can't wait to see what you create. Certainly do share it with me. With that being said, let's go ahead and get started. Let's consider our development processes for a mobile application because we're developing software that's going onto hardware that we don't own and therefore we don't control. So we have to really think a lot about quality and how we can make sure that we're pushing a quality app out to the device. If we have a quality issue, it's much harder to control on hardware that we do not own. So several steps we're going to take. First of all, we're going to consider test-driven design and behavior-driven design. A big reason for this is we want to make sure that the testing gets done. In the old days of waterfall, we would come up with our analysis of the software, then we would design the software with things like flowcharts and class diagrams, then we would implement the software, then we would test the software, then we would release the software. Well, if that release date's hard and everything behind it is running behind, what gets squeezed? Well, the last thing that has not been done yet, which is the testing. So oftentimes in waterfall, that testing step would get squeezed a little bit. But with test-driven design, we write the test up front. And then when we write code that makes those tests pass, we know that the feature is complete. But we need some way to make sure that those tests are related to the requirements or the analysis that we came up with to write the software. And that's where behavior-driven design comes in. Behavior-driven design means that anyone can come up with a test. And that's a huge benefit, because if you think of who could have input to a test, it could be the quality department, it could be software developers, could be a product owner, could be a scrum master, it could be anyone. And as Bill Nye says, everybody I meet knows something I don't. So we get to leverage everybody's unique experience and talents and come up with a full suite of tests that represent our requirements. So that's test-driven design. And then behavior-driven design is using an English-like language, or whatever your native language is, to describe or elaborate the requirements into a series of examples. Examples that elaborate those requirements. Now, we write very specific examples using behavior-driven design because we're going to take those and make a script out of them, and that script is going to be our unit test. The unit test will fail because we don't yet have the code to make it pass. Then we're going to write the feature, which is the code that's going to make that unit test pass, and as soon as the unit test pass, we know that feature is complete. So, if we take a look at our Android development environment, we can see that I have created several unit and integration tests here, and they've matched very closely to the requirements because take a look at what the test is called. Given a view model with live data. So we have a precondition. When populated with plants. So we have an action step that's going to happen. Then results show eastern redbud. That gives us something to verify. So you see, this is English language. We even have spaces in this function name. And this is something that anybody could come up with given a requirement that we want to be able to enter specimens that are related to plants. Someone might say, okay, sure. Well, given that we have a view model, when it's populated with plant data, then we should see eastern redbud in that plant data. So from requirement to test, from test to code, and then from code, we want the test to pass. So we can certainly run these tests locally. You see within my IDE, I have an option to right-click and run each of these tests. But another key that we want to think about is how we can make it compulsory. In other words, how can we make running the tests automatic so that we know that our tests are passing, and if they're not passing, we know what test is not passing, and we know that we can go remedy that broken test. Well, that's where we have another thing that we get to look at, which is CI/CD, or continuous integration, continuous deployment, continuous integration, continuous delivery. Depending on how you define that acronym, either one is just fine. And what that means is every time we do a commit and push to our version control system, which in this case is GitHub, it's going to run through a series of value-added events with the CI/CD tool. The tool that I'm using is CircleCI. There are several others that you can use. Jenkins is quite popular. GitHub Actions is a bit newer, but certainly up and coming. And you see that every time I do a commit and push, it's going to run the series of value-added steps. And it's integrated well with GitHub so that it will give me a red X if something goes wrong, or a green check if everything worked out right. Now I can click on this check or this X, and I can click on details, and it will take me right into my CI/CD pipeline, and it will show me the steps that have run. Typically, it's going to set up the environment. Then it's going to do a build. You should verify that your code does build, because you should never commit and push broken code to version control. In other words, everything you commit and push should compile, because your teammates deserve to have a good foundation to build on, and that good foundation should be compiling code. If you commit code and it doesn't compile, stop everything you're doing and fix it, because that's a big no-no. So CircleCI will run this build and tell you whether it passed or not. After that, it's going to run the tests, and those are the very same tests that I just showed you in the IDE. So by having this automatic, by having this compulsory, we know that it's going to run and we can get that immediate feedback. So while I've been talking about CircleCI, I've also talked about its integration with GitHub. And GitHub is also something that we want to use, or some type of version control software, because we could have one person working on an application, but more commonly we're going to have multiple people working on an application. Again, all of that experience that everybody brings to the table adds value to our application and makes an application that is going to be usable by more people. So we could have dozens of people working on an application. We could have hundreds, and we could have weekly releases. So how do we coordinate all of this stuff going into our application and also releasing a quality application to the customer on a weekly basis, possibly? Well, what we'll do is we'll have our master branch, which is more commonly now known as main branch. So I'll call it main from now on. But that's kind of like our gold copy. What goes in there should be stuff that compiles and features that meet the definition of done. In other words, they're code complete, they've been quality checked, they have unit tests wrapped around them, so on and so forth. We don't want work in progress in our main branch. Work in progress should belong in feature branches. So if we take a look under main or master here, we'll see a series of feature branches like Firebase Authentication. And this is how I have organized the videos in the playlist, is that each big feature is its own branch. And each feature takes about a week. Well, I consider it a lesson, which I would consider about a week's worth of work. So each feature is kind of a bite-sized week's worth of work that has its own feature branch. So when you're going through the videos, if you want to see how to do something specific, you certainly could go to main or master, because everything eventually gets merged there. And at this point, I have merged all my feature branches because they do meet the definition of done. But the trick is that you have to kind of find the specific commit for that thing that you want to do. On the other hand, you can go to a specific feature branch and you can see the code that I was doing at that point in time to make that feature happen. And you don't have to worry about any work that happens subsequent to that, because that feature branch is frozen in time when I made that feature. So that will hopefully make this a bit more bite-sized and a bit more easier to learn. So we're using GitHub. We have our unit tests built into GitHub, but then we're also using Agile and Scrum, and each lesson is one feature. Each feature corresponds to one branch, so you can very easily navigate and find exactly what you need to accomplish the task that you want to do. When we develop an application, we're essentially assembling together several ingredients that we have at our disposal. And so I want to take a look at some of these ingredients that we're going to use. Some we make just by assembling together other things and putting them together. So for example, our autocomplete is going to be us assembling several things from Jetpack Compose, which is the UI framework that we're using in this application. JSON parsing, we're going to use a third-party library called Retrofit. Then we get into some of the Android API things like Jetpack Compose, the Android operating system, model view model, live data, and then some things that we can leverage that are on the device or available through the Android operating system, including Room Database, which is a database that lives locally on the device, and also GPS coordinates. Then we'll take a look at how we can integrate a third-party app to some degree. It's Firebase, which is owned by Google, which also essentially owns the Android operating system, the Android ecosystem. So very closely related and a very easy integration, and it makes for very easy application development. And then we'll finally take a look at Google Maps to see how we can create data by getting data from the user and also by getting GPS data. And then we can show that data to the user on a Google map. Let's explore a little bit about the Android development environment and the Android API that we're going to be using to develop this application. So Jetpack Compose and Android Q. Actually, I ended up bumping it up a little bit and going to Android APK between 30 and 32, which is very, very new at the time of this recording. Jetpack Compose is a new framework in Android, also very new. I wanted to cover something very much leading edge. And in that case, we are programmatically creating this front end. So in the older layout, we used to use an XML-based look and feel where we would put widgets on the screen in XML, and then we would access those widgets from our activity, which is essentially the class that's handling our UI logic and our view logic. Jetpack Compose is a bit of a different paradigm, and as I mentioned, a very new paradigm as well. In that case, we're pushing data to Jetpack Compose, and then Jetpack Compose takes that data and decides how it's going to render the screen. So the screen is rendered based on the data, in other words. And also Jetpack Compose is observing data and looking for changes. And if the state of the data changes, or the value of the data changes, in other words, Jetpack Compose will automatically update the user interface. So this is entirely a Jetpack Compose user interface that we're looking at. The spinner is this thing at the top that shows us all of our specimens, and you see that we can click between and among the specimens and see details about those specimens, and we can update those specimens as well. I will say Jetpack Compose is a bit young at this point, and I wasn't able to find a spinner component out of the box, so I found one that somebody had provided on Stack Overflow, and I adapted that. That took a little more work than I had hoped it would take, but it did nonetheless give me the results I eventually wanted, of that ability to select something from a dropdown and then populate other fields based on that dropdown. Another component that I used is Autocomplete. So see if we go to New Specimen, we have an option here for plant name, and I can start typing something like SOU, and it will autocomplete with Southern, essentially. And as I continue to type, it will continue to autocomplete. Southern Magnolia as soon as I type in Southern M. So autocomplete I consider to be a very important tool to use when writing a mobile app, because we want the user to be able to interact with our app in a very minimal way. In other words, not a lot of button presses, not a lot of screen changes, things like that. If we want to deliver value to the user very quickly, and an autocomplete is a good way to do that. We also like standardized data. If I say plant name, there are a lot of different variations we could have on a plant name. Someone might call it a Southern Magnolia, someone might call it a Southern Mag, they might call it Magnolia grandiflora, which is the Latin name for it, or they might call it a big tree. But by having a predefined list of acceptable answers, we have better control over the data that the user is entering, and therefore data that we're seeing on the back side. So we have to have a source of this data, and this is what I use. I use a feed of JSON data that's available online. Consider that for your application. Where can you find data that you could integrate with your application to make a better app? I have a couple of places that I recommend. I have a website, jasonservices.com, that has a listing of some JSON services that I found helpful in mobile app development. But think seriously about that. Where can you find data that you can integrate into your mobile app to make it a better mobile app? Now, a few other considerations. Remember that that's an autocomplete, so as the user's typing, it's narrowing down that list. When I initially set up this autocomplete, I'm hitting this data source live. But the trick is there's going to be network latency in going to get that data and show it in the autocomplete, which is not an ideal experience. If we have something like an autocomplete on our screen, we want to source it from local data. So in that case, I'm saving the data locally into a room database, which is a database that lives on the device itself. So it's a good place to cache data. So pull the data in from JSON, replicate it locally on the device with room so that the data is close to where it's going to be used and there's not latency that the user will see. I will say that autocomplete component, similar to the spinner component, I didn't see an autocomplete component in Jetpack Compose, but there again, we're very early on. We're in version 1.0.0 of Compose, so pretty much the very first version. And I was kind of surprised not to find an autocomplete component in the Jetpack Compose library at this time, but I did find a good solution on Stack Overflow. I altered it to make it work for us. It did take a little more effort than I thought it would take, but we're going to see the payoff a little bit later in this playlist, where we see how all of these things integrate so well together and the value that we get from that integration. A couple other things I use: model view, view model with live data. So we know live data means that we have an app that can respond to data as it changes and update the UI as it changes. We'll see that in a moment when I talk about Google Maps. I'll show a live demo of that. And model view, view model means that we have the user interface logic purely in this thing called an activity in the state or the data in a view model. And we can switch activities and use the same view model so that the data automatically goes from one activity to another. Again, we'll see that in just a moment when I demonstrate Google Maps. Now, ideally, we want to do as much as we can on one simple screen without having the user navigate from one screen to another. So I'll show you something that I put together that allows us to do this, and also allows us to see multiple pieces of information at once and edit multiple pieces of information at once. In the Specimen Spinner, I'm going to go back to this Westerland Rose. And what we'll notice is that I have something called a lazy column down below, which is where I have a series of repeating sets of data. And in this case, it's essentially a photo. So I can click on the photo button. I can take a picture once I give permission. And our photo emulator comes up in the emulator. And each of these cells that you see down here represents a photo that we've taken of the plant. Now here's the neat thing. We have a photo ID and then we have the time and date it was taken. Those aren't likely to change because we capture those at the time we take the photo. But down here in description we can say something like spring blooms. Unfortunately it's a bit off screen, but nonetheless we will see in just a moment that it will update. And then we can simply hit a checkbox and it will save that. So you see we can edit each of these photos in line. We can also click the delete button to remove a photo and the data associated with that photo. I've discussed a few concepts. Let me just show you where they are on our class diagram. So first of all, for JSON, we're going to need retrofit client instance. And we're also going to need a DAO that can go out and parse that JSON, and a data class or a DTO that can hold the JSON data. Now we're going to take that DTO, we're going to make objects out of it based on the JSON data. We're going to store that in Room. So for that we need a class, and actually need to move this guy. We need a class that extends from Room Database, which in this case I'm calling Specimen Database. We also need our DTO just as we had before, and we need a DAO. So that's Room. I mentioned model view, view model, so we remember that the state is here in this view model, and the UI logic is here in this main activity. Now really I could add another activity, which is the maps activity, which I should add because that does exist in our project. And that maps activity is going to use that very same view model. So all of the concepts that I'm talking through right now, I have represented on this class diagram. Now we have GPS. And GPS is another one of those things that's just incredible functionality. When I think back to my days in undergrad, we were programming for mainframes, we were programming for servers, and maybe PCs. But we never had this idea that you would have location data available on the computer and that the computer would be mobile. That is your mobile phone. And then we would also have a whole series of data that's indexed by location, like things that are around you. The potential for really writing an earth-shattering app based on GPS is just amazing. So we're going to take a look at how to do that. You notice up here I have 39.10 and minus 84.51, which puts me roughly downtown Cincinnati. I can put in a new location if I wish. So I could say 500 Vine Street, Cincinnati, and it's going to put it right around Fountain Square, and then I can say set my location. And within about a minute, just remember some of the numbers over here on the right, because in about a minute you're going to see those update. It checks every minute for location updates, so we'll see that update to a different number. And then we can associate that with a specimen that we're creating right now. And now you see 39.10117 minus 84.51297. Sure enough, those GPS locations have changed. One major revolution that's happened in the time that we've had mobile device programming is the advent of the cloud. And in mobile, specifically Firebase, which has a lot of really nice features that we can use to develop a very functional mobile app and develop a very functional mobile app quickly. So the probably middle to later part of the video series is really going to take a look at how we can leverage Firebase. And I want to walk through some of those features right now. So first of all, we have authentication with Firebase, then we have Firebase Cloud Storage and Firebase Cloud Firestore. So if we take a look at our application, I have a logon button there. Now, one big caution about logon, actually two big cautions. One is, a lot of times when I see app designs, designers and developers feel like they need to make the user log on first thing before the user does anything, but resist that urge. Let the user play with your app a little bit and only prompt for logon when the user needs to save something, because users want to be able to try things out before they're committed to giving some personal details. So that's number one. As a matter of fact, the logon button here I would not have on a live application. What I would do instead is, as soon as the user wants to save something, I would prompt to log on then, but I wouldn't make the user actually hit a button to log on, because the app knows when we need authentication better than the user knows. And we typically need authentication when we are saving or reading some private data. So that's number one. Number two, resist the urge to write your own logon screen. Early on in Android development, a lot of times I would see people or groups form a project and write a logon screen and then get stuck there and never get to their core functionality. So logon screen is probably not your core functionality. Hopefully not. Hopefully you're looking at some kind of integration or something that's adding value over and above that is your core competency, and focus on that, because login can get complicated. At first you think, oh yeah, I just need to prompt for username, password, but what about password resets? What about forgotten usernames? And very importantly, what about integration with other logon providers so that the user doesn't even have to remember a new username and password for your application? Well, that's all made very simple with Firebase Auth. So I'm going to go ahead and choose logon here, and it's going to take me over to a user interface that is provided by Firebase Auth. And you'll see that we have a couple of options here. One is sign in with email, the other is sign in with Google. And we actually can add more login providers to that. Twitter, Microsoft, Apple, Facebook. Lots of places where users already log in, and we can use essentially third-party login. So I'm going to go ahead and say sign in with Google. And I've already signed in on this device, so it's going to recognize my account, and it probably will not prompt me for a password because I've already logged into this device. But if it were my first time on this device, it would prompt me for a password. Or if I chose that email prompt, then I could create my own password. And Firebase Auth even handles all of the mechanisms of resetting your password and all of that overhead stuff that you really don't want to bother with. So now that I have logged on, let's take a look at the specimens dropdown, and you see that it recognizes 3 of the specimens that I already created when I was logged on with this account. And I can click and I can see the details, but I see only the details from my specimens. I'm not seeing details from another user. Let's see how we can implement this on the cloud side, on the Firestore side. You notice that Firebase Authentication tells us who's logged in, what the provider is, and gives us a little unique ID. Now let's remember, for my email address, this unique ID starts with YLIF. Okay, hold that thought for just a moment, because I'm about to jump into the next concept we're going to discuss, which is Firebase Cloud Firestore and Firebase Cloud Storage. So once again, remember YLIF, so on and so forth. So A nice thing about Firebase handling the authentication for us is that we can leverage this authentication mechanism all the way across Firebase, including Firebase Database, where we'll store data in JSON form under the covers, but we just see ourselves saving Kotlin objects essentially. And also Firebase Cloud Storage, which is where we can store binary things like pictures, videos, music clips, so on and so forth. They're all integrated with this auth framework. So what I can do now is go to Firebase Database, and notice when I click on users, YLIF, does that ring a bell? So you see that I start this hierarchical model of collection to document to collection to document to collection to document as Firebase Cloud Firestore is set up. And the first actually document to collection set that I have is users, and then under that I have a collection of users, and under YLIF, the login ID that we saw earlier, we can see all of the specimens that are specific to me. And I can click on this first one and we see Westerland Rose, which is one of the ones that I clicked on that spinner dropdown. And then we can dig down and we can see photos. Now, a couple other notes here. When we go to photos, you'll notice that there is a local URI and remote URI, but you do not physically see a photo here. That's because Firebase Database or Firebase Cloud Firestore just holds data. It doesn't hold binary data. It just holds like text JSON data. But Firebase Cloud Storage does store binary data, and what we can effectively do is take a pointer from Firebase Cloud Storage and insert that pointer into the Firebase Database, also known as Firebase Cloud Firestore, so we can associate the two together. So if we take a look at this, we see there's Firebase Storage, Google APIs, so on and so forth, and it's pointing us to a specific location here. Now I can go to Firebase Storage, and we can see a very similar route that we just saw in the database, where I start with images, but then under images I have a user directory. Just like we have here in the database where we have users and then once again YLIF. Well, guess what's neat about that is we can create a series of rules that says only this logged in user can look at the information that's within this directory, and therefore you have the concept of a private directory. You're not able to jump over to somebody else's directory and see their images. So a very powerful concept. All of these things together really help us to develop our app quickly because now we have authentication, now we have persistence for data, now we have persistence for binary data. And one other really nice thing that Firebase gives us is automatic synchronization between device and the cloud, and between device and device, which is really incredible. If you're logged on to multiple devices, it will keep them in sync automatically. Before Firebase, it took me about 3 lectures to get through that very concept of how to do online-offline sync. But now with Firebase, we can do that in basically half a lecture, which gives us a lot more time to explore a lot other neat functionalities that we can put together. Now let's take a look at Google Maps. A nice thing is that we have collected GPS data for all of our specimen records. And a GPS as a number doesn't mean a whole lot to a human, but the neat thing is with that GPS number, we can display these things on a map, and that gives it context, which a human can understand. Google Map is fairly straightforward to set up in our application. I've put it under this Map button, and we see it renders. And if I navigate down here around downtown Cincinnati, you can see that I have 3 GPS points, and I certainly could add more. We can click on them and we can see Westerland Rose. You see we have something in bold, which is the title of the plant, and then we have the plant name below it. And we can click on each of these and see the plants that are there, and it recenters the map. This is, I will say, for the value this delivers, it is surprisingly easier to do. But let me show you one other thing that is really awesome. So we know that we've wired all these data up in the cloud using Firebase Cloud Firestore. We also know that we're using live data to update the user interface automatically as the data changes, and we're listening for those data to change. So we have our Westerland Rose right out here. Now we have that record here in Firebase Cloud Firestore. What if I bump the latitude just slightly? What if I make it 39.12? you notice that that point automatically updates on the map as I change the data in the cloud. Similarly, what if I change the longitude? What if instead of minus 84.55, I made it minus 84.53? And you see, as soon as I update, it moves it over to the right. So this combination of Model View model with live data and Jetpack Compose that's listening to that live data in a Google map that is also based in Jetpack Compose and the cloud-based data means that we can have our map update automatically as the data behind the scenes changes. And it actually does not take as much work as you might think because we built that framework early on, and now we're leveraging that framework. Now let's take a look at a few videos that I'm currently working on, which will be available soon. First of all, Dialog Box. Dialog Box is a good way to make a very functional application with minimal screens because you can use a concept called progressive disclosure. And progressive disclosure means you keep a very simple user interface and you only make it more complicated when the user asks for it to be more complicated. So for example, you could set up a meeting and then have a repeat. Does it repeat checkbox? When you click that checkbox or click that button, then you see the options on do you want it daily, weekly, monthly, so on and so forth. And you only see those if you actually ask to see them. So this is something that we can accomplish either by making the screen grow and shrink, or we can potentially pop it up with a dialog box and ask for more information there. But we're still keeping the user focused on that one activity, so it's a simpler view for the user and a simpler user interface for us to design because we're keeping everything on one screen instead of having multiple screens and having to navigate back and forth among multiple screens. Next item is Geofence, and Geofence is a very powerful tool and a time when we can really take advantage of the mobile nature of our device. And we can say, here's a GPS point, and then we can put a fence around it, either a circular fence or a polygon around it. And as soon as a user enters or exits that fence, we can have it trigger an event that a broadcast receiver listens to. And then that broadcast receiver can take some action. It could be something like, you're near the store, here's a special, or you're near the store, or you're running low on milk, something like that, something that's really location-based and event-based. A very powerful tool. So that's a look at the app that we're going to be developing through this series of videos and also through GitHub and our weekly commits and our branches. We're going to use a lot of development best practices. So we're definitely developing an app. We're also looking at how to develop an app in a very efficient manner, especially when we're developing with multiple developers, which is very common these days, especially for high quality apps that you see out on the Play Store, where you could have 100 developers working on it at once and have weekly releases. So a lot of complications that need to be managed when we're doing that. We're going to be a little bit smaller than that. We're going to be a smaller group, and we're going to have less frequent releases, so to speak. But nonetheless, this gives you the framework that you need to either develop an app on your own or develop an app in a group-based setting or develop an app in a corporate setting that has that frequency of releases and has a number of skilled and talented individuals working on the app. One thing that really excites me about this is the ability to really change the world by writing software and delivering it in a very easy way. These are things that we simply didn't have when I was an undergrad many years ago. The concept that everybody would have a computer on them at all times, and that computer would have a camera, it would have GPS, it would have contacts list, it would have all kinds of other things. And these are simply the raw materials or the ingredients that we as software developers have to put together and make something great. So I hope that this video series inspires you to make something great as well. And if so, I'd really like to see it. So please do share it with me and let me know how it goes. Thank you.